Welcome to Topic 6, Lesson 4, Models for Multiplying Decimals. So in this video, we're going to show how you can visually show how decimals are multiplied. We're going to do that a couple different ways, and then we're actually going to look at an algorithm for multiplying decimals. So our first model, we're going to look at 3 times 5/10, which would be the same as 3 groups of 5/10. So remember, a multiplication sign is like saying groups of. So if we did 2 times 5, that's like saying 2 groups of 5. 2 groups of 5. And 2 groups of 5 equals 10. So, but in this case, we're doing 3 groups of 5/10. So I'm going to make mine, I'm going to do a little bit. So I'll do my first group of 5/10. Then I'm going to do my second group of 5/10. Then I'm going to do my third group of 5/10. And if I counted up, I would have how many hundreds? So each one of these blocks is a hundredth, right? I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I would have 15 hundredths because I have 3 groups of 5/10. Didn't need all these other grids, I guess. But it would be the same multiplying any whole number by a decimal. Okay, now, but where it starts to get a little bit more confusing is when you start multiplying a decimal by a decimal. So in this case, so we're going to start with our 4/10. So in the same thing, I want 4/10 groups of 3/10. So it's going to be a really small number, right? Because I'm having less than one group of less than one. So it's going to be fairly small. So to show this, I'm going to do this a little bit differently. I'm going to start by coloring in 4/10. Okay, so I've colored in 4/10 reasonably well. Now, so that's in this direction, right? I got 4/10. In the other direction, I want 3/10 of that 4/10. I want 3/10 of that. So I'm going to go in the other direction. I'm going to color in 3/10. Oops, not thick enough. Okay, let's just color that in. Okay, so I have 4/10 going in this way, then I have 3/10 going in this way. I want 4/10 of the 3/10. So if I take and I put a box around where those two things meet, that is 4/10 of 3/10. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 hundredths because that's 4/10 going in this direction, 3/10 going in this direction. Where they overlap, that's 4/10 of 3/10. It's really hard to show this when you start getting into larger numbers that are greater than 0 times the number that's greater than 0. It starts to get a little trickier. But with a decimal a decimal lower than 1 by a decimal lower than 1, that's how you show that in a picture. It's where those two things overlap because it's 4/10 of 3/10. Now I could have put the 3/10 here and the 4/10 there, right? Because of the commutative property. It wouldn't matter which. It doesn't matter which side the graph you're using. Okay. So that's great, but you can't going around drawing graphs, right? That just is not going to work for your life. That would be a lot of work. So this is how you actually do this. what you do is you start by just multiplying your numbers. You don't even worry about the decimals to begin with. So I'm gonna when you first do this, you just think of 36 times 4. 6 times 4 is 24. 4, carry the 2. 3 times 4 is 12. Plus 2 is 12. So I had 144. Then what you have to do is you have to decide where to put the decimal. And you can think from the last couple lessons, you might even be able to do it without even doing this method. You could think, well, I want 36 hundredths of 4. What makes the most sense would be to put the decimal there, right? Because if you put the decimal there, it would be 14. That would be way too high. And if you put it there, it would be too low. So it kind of makes sense. There's a reasonable answer here. But the way you do this is you count how many decimal places there are in each factor. So there's 1, 2 factors, and 3600. There two decimal places, and there's no decimal places in the 4. Then you count those up. So 2 plus 0 equals 2. And you move over 1, 2 decimal places. So let me give you another example. Like in 2 and 5/10, there's 1 decimal place in that answer. In that number. And 3 and 652 thousandths, there's 1, 2, 3 decimal places. You just count how many places you have to move that decimal to get it to be a whole number. In a whole number like 6, there's 0 decimal places. In a number like 3.62571, there's 1, 2, 3, 4, 5 decimal places. Okay, and then you just count how many there are, and then you add them together from both factors, and then you move that way in the other direction. So let me just do another real quick. If I were to do 2 and 5/10 times 6,700, so I'm giving myself something hard. Okay, 5, 3. How did that happen? 5, carry the 3. 14 would be 17, 0, 0, 3. You're going to have to trust me on the number. That's not really there. Okay. I have 1 decimal place here. We'll even do a little bit. I got 1 decimal place there, and I got 2 decimal places there. So I got 1, 2. 1 plus 2 is 3. Now I'm going to move over 1, 2, 3 decimal places. So my answer would be 1 in 675 thousandths. Okay, why don't you try? I got 2 for you to try. Okay, let's try these together. So the first one was 3 and 4/10 times 2 and 3/10. 4 times 3 is 12. Carry the 1. 9 plus 1 is 10. I'm going to do the multiplication part. I'm doing fairly quickly because at this point, you should be able to do the multiplication parts. Okay, so I got 782. I like my little dotted line here. I got 1 decimal place here, 1 decimal place here. 1 plus 1 is 2. So now I'm going to move over 2 decimal places. So 7 and 82 hundredths. Okay, now my other one was 2 and 7/10 is a little bit easier. 7 times 3 is 21. Carry the 2. 3 times 2 is 6 plus 2 is 8. I've got 1 decimal place, 1 decimal place. So 1 plus 1 is 2. So we're going to move this over 1, 2 decimal places. 81 hundredths would be our answer. Okay. Thank you for listening.